Welcome to The Explainer. Today, we're looking at something absolutely massive that Google just dropped. I mean, they just open sourced a breakthrough that completely, fundamentally changes how AI generates text. If you use AI every day, you're absolutely going to want to pay close attention to this because we might literally be looking at the end of the AI typewriter.
So let's just dive right into it. Think about every time you use an AI chatbot. You type in your prompt, you hit enter, and then you wait. You know that feeling, right? That agonizingly long pause where you're just staring at a blinking cursor while the AI slowly types out its response, word by single word. Why is it that our incredibly advanced, ridiculously expensive technology always seems to keep us waiting in line?
Section 1, the typewriter bottleneck, waiting on words.
To really get why this delay happens, we gotta look under the hood at the architecture. Pretty much every major chatbot today, we're talking ChatGPT, Claude, Gemini, Grok, Llama, all of them, they work the exact same way. It's called an autoregressive model. Basically, that means it predicts one single word, then the next word, and so on, working left to right exactly like a plodding, old-fashioned typewriter. Now, this design literally built the generative AI boom, but it creates a massive bottleneck. Since the system works sequentially, every new word has to wait for the previous one to finish. So your incredibly expensive GPU is actually spending a massive chunk of its time just sitting there, twiddling its thumbs, waiting for its turn.
Section 2, the diffusion canvas, the breakthrough. Well, Google just totally flipped the script with a new model called DiffusionGemma. To understand it, think about how modern AI image generators work, like Midjourney or Stable Diffusion. They don't draw an image pixel by pixel from left to right, do they? No, they start with pure visual noise, just static, and refine the whole thing until an image comes into focus. Google basically asked, what if text generation worked exactly like that? Instead of writing word by word, DiffusionGemma treats text like a sculptor treats a block of clay. It engages an entire block of text all at once. It starts with a canvas of random placeholder tokens, pure noise, and then, in multiple passes, it keeps the parts that make sense, fixes the parts that don't, and slowly sharpens the entire block into a coherent paragraph, all simultaneously.
Moving on to Section 3, the need for speed, faster generation.
Ditching that old word-by-word method brings us to a frankly unbelievable benefit. When you completely eliminate the typewriter bottleneck, the results are incredible. Google is reporting that DiffusionGemma can generate more than 1,000 tokens per second on a single NVIDIA H100. That is just blindingly fast. You're completely kissing that frustrating AI wait time goodbye.
And it actually gets even better for everyday users. Even if you're just running a consumer-level RTX 5090 gaming GPU, this model is still hitting 700 tokens per second. That is roughly 4 times faster than traditional language models running on that exact same hardware. Just think about how much of a game changer that is if you're waiting on giant blocks of code or massive document edits.
But here's the absolute best part. DiffusionGemma isn't locked behind some expensive API or a rigid subscription tier. Google actually open-sourced the weights under an Apache 2.0 license. That means, yes, commercial use is completely allowed. Any local developer can take this architecture right now, build on top of it, and completely eliminate those code generation wait times on their own machines.
Which brings us to Section 4, an AI that edits itself, self-correction. Because raw speed isn't the only superpower here. You see, traditional AI models only see the past. They know what they just typed, but they're totally blind to what's coming next. But DiffusionGemma evaluates the entire block simultaneously. It sees the beginning, the middle, and the end all at once. And because of that, it can actually revise, adjust, reevaluate, and improve the text before it even hits your screen. It can literally self-correct. And honestly, that perfectly mirrors how humans write. We don't just spit out a flawless sentence from left to right on the very first try. We draft, we edit, and we rewrite in one fluid process. And there's a really brilliant test that illustrates why this big picture view is so important. Google tested this model using a Sudoku puzzle. Now, Sudoku is famously difficult for traditional AI because your early answers depend entirely on numbers and constraints that show up much later on the board. A left-to-right model just faceplants because it can only move forward. But because DiffusionGemma evaluates the whole board at once, a fine-tuned version leaped up to an 80% accuracy rate. That's up from basically 0 on the base model. It absolutely proves that for tasks needing global planning and reasoning, this diffusion method is remarkably powerful.
All right, time for a quick reality check in Section 5, the experimental catch. The caveats.
Now, before we declare the total death of traditional large language models, let's pump the brakes for a second. Google is very clear about a few major caveats.
First off, this is a highly experimental model right now. In terms of pure conversational intelligence, the output quality is actually sitting below their standard Gemma 4 models. Plus, while it's blazing fast locally, the cloud economics are currently a lot worse when you have thousands of users sharing the exact same server. So, no, DiffusionGemma is not going to magically replace ChatGPT, Claude, or Gemini tomorrow morning.
Finally, Section 6, a new AI paradigm, the future.
Even with those caveats, we really can't understate what this represents. For nearly a decade, the entire AI industry just assumed that the autoregressive, one token then the next model was the undisputed future. Everything was built around that single idea. What this explainer highlights is that text generation can actually match the block-level efficiency and the self-correction we've seen in image models. Google has successfully proven that the future of text AI might look completely different than the tools we rely on today.
Which leaves us with a really fascinating question to ponder. Would you willingly use a blazing fast AI on a daily basis, even if the raw output quality was just a tiny bit lower? And looking ahead, do you think this diffusion-based approach will eventually overthrow the standard ChatGPT-style systems entirely? Think about how you weigh speed versus quality in your own workflow. That's all for today's explainer. Thanks so much for joining me, and keep exploring.